Plotting in Matlab Part 3. In today's lecture, we are going to see about Matlab functions STEM, FPLOT, PLOT3, and STEM3. So pretty much STEM is used for plotting discrete time sequences. The FPLOT is called as a function plot. We will see it helps us to plot y equal to f of x. Then PLOT3 is a three-dimensional data plotting, and STEM3 is a three-dimensional data plotting. So this is also a three-dimensional data plotting. For discrete, I can say this is a discrete plot. Okay, so let's get started. So to begin with, we will see how we can use STEM to plot your discrete time data. So I'm going to create some input data. So I'm increasing the number of samples from -10 to 10 in 50 numbers. So let's see what do I get here. So let me just keep this as 10 and then see the output. If I show here, so my input data is from -10 to 10 and I have 10 samples. Okay, I'm taking the sign of this input data. So what I'm doing is I'm creating in some input data which is a linear space data. The difference between the two data are the same. I'm taking the linear space data with the linspace function, and then I'm creating a sign information. I'm taking the trigonometric sign of that input data, and then I'm counting the number of samples using the length function. So this is going to give me the number of samples of my input data. I pretty much don't need it, this x data at this point. I'll just comment to that one. And then I'm going to plot my x data comma input data. So my x data is at this point, I have just deleted it. I'll just instead of this, I'll keep it as 1 is to number of samples. Okay, so whatever the number of samples here, and then you can see that I get a STEM graph. So this is called as a STEM graph. So it's different from a continuous graph where each value is plotted in its own. So this is the number of samples as the x-axis, the sign input data. So at value -4, okay, I'll just have to run it again because I've changed the range. Okay, at value 0, I have no values. At value 1, I have something 0.6. Value 2, I have -1, etc., etc. So this is how a STEM graph look like, and this kind of signal is called as a discrete time signal or a discrete signal. So when we say discrete signal, it means a signal which is having few points. That is pretty much what it means. A discrete signal is a signal with few points. Signal with few points. And if you see, when I increase this number of points, so let's say I go from 10 to 100. So now I'm generating 100 points, and then I'm plotting. You can see that this more looks like a continuous graph. You can see the sine wave shape. You can see, it's more approximation. So as you increase the number of samples, the discrete signal approximates to continuous signal. So this is a continuous signal. You cannot tell the difference with this, that this is a discrete signal or a continuous signal. This more, if for a professional eye, this looks like a continuous signal. So even though I'm plotting it with the STEM. So that is why we need to use fewer samples to see the effect of STEM, because the STEM is used on discrete signal, which consists of signal with few points / samples. Alright, another thing here is the use of keyword filled. So when I use the keyword filled, I'm going to fill these STEM markers. So you can see the default STEM marker is the round circle, and it's going to get filled, and it's going to give a bit of good visual appearance. And I normally leave it on whenever I do a STEM plot. And the next thing is with STEM is the x data. So if you don't give the x data, so if you see here, we are plotting two STEM graphs. So in this STEM, I have not given the x data, and here I have mentioned the x data and the y data. So if you don't mention your x data, what happens is by default the Matlab assumes it starts from 0 and it increments till the number of samples. So if you have 50 samples, it goes from 0 to 50. If you have 25 samples, it goes from 0 to 25. So this is the default Matlab settings for the x data or the x-axis plot value. So now what we are going to do here, in case if I am having my x data to be not the default, so let's say that's what I have from -5 till number of samples this way. So now if you see here, the x-axis is from -5 to 20. So I modified, then you need to specify, because the default setting will still plot it from 0 to 25. But if your x-axis is from -5 to 20, it's not in the default range, then you have to mention your x-axis and along with the y-axis, and then you can get it plotted in that way here. So this is pretty much how you use STEM graph for plotting discrete time signals. Like I said, if your number of samples is less than 50, then it's always best to use the STEM option. And if you have greater number of samples in your signal, then go for your continuous signal, which is just plot. And then this fill keyword, and another useful thing, use fill keyword to fill the marker of STEM. So this will help you get a better visual appearance, and you all know what is an X label and Y label MIDOM. So it's just for labeling my graph. Okay, next we will go into some properties on how to display the STEM marker and other options. So we are plotting the STEM, and then what we are going to do is I am just going to take that property, STEM property. So I'm just going to do this here. I'm just going to make this H data. Let us see, when I run this, I'm calling H data, I'm making H data is equal to STEM. Then you can see that Matlab displays these properties. This is very useful. So it says that your STEM is having these properties. And then what I'm doing is, okay, I want to modify some of these properties, and that's what I'm doing next. So I'm going to call this H data. So H data is having all these properties, and I'm going to change the color to green. So here I don't know what the color is, but I can see that it's a blue color. So I'm going to change it to green, and the line style I'm going to change it to a dotted line. This is a straight line. I'm going to make it into a dotted line. Marker size I'm increasing from 6 to 10. The marker, it is the same thing. We'll just put some, we'll keep that because that filling in color, and the marker color. So marker color I'm keeping it as red, so which is blue here. So let us see what happens here. Then if I run this program, you can see that the marker, all the properties have changed. So it's a dashed line, it's a red marker, the marker size has increased to 10. So all the things that we have mentioned here has been applied to this STEM. I pretty much prefer this option for modifying my graph visually because it's very easy. You don't have to remember these keywords. You can all, and if you click on this show all properties, you will get the list of all the properties that you can work with H data. So you just have to call these properties as H data dot that property name, and then you can just give it that whatever the custom value that you want to give. Then you will be able to modify your graph. This can be done in a single. Another way also you can do this, though this is directly giving it as an argument. So this is what is given in Matlab help and most of the Matlab examples that you see out there. And this is also pretty convenient because you get all the things in a single statement. But what I don't like with this is you must remember what all things is there. So that comes with practice, and even with practice you may not remember all the properties, because if you click this show property, it's taking to a different window which I cannot show here. But this property will have around more than 100 titles. So more than 100 titles come under these properties, and it's difficult or impossible to remember all the names, all the properties for modification at a later stage. So when you use it in this manner, so you just have, it just means that you know these properties, some of the very common properties like line style, marker color, line width. So these kind of things you can change, but some of the complex properties, or which are the less frequently used properties, you may have to still go with this referencing. So when you call it without the semicolon, so why you are able to see this property is I have not put the semicolon. So if I don't put the semicolon, you will see all the properties, and if I put the semicolon, it just disappears. So you won't be seeing these properties at all. You will just see the graph. Next, we are going to see how to do multiple STEM graphs. So we have seen this with plot window also, how to do a multiple plot within the same window. So I am creating two input data, input data 1 and input data 2. So input data 1 is my sine of input, data 2 is cos of input. And then how do I plot it on the same graph? Using the hold on and hold off command. So I create a new figure to initialize this. Why I do this is if I don't put the figure option, sometimes it overwrites on the existing figure. So we don't want that. So figure will create a new figure, and then it's going to plot these two graphs, the sine graph and the cos graph, because I'm giving this hold on and hold. Next, what I'm giving here is I'm giving this padded option. So the axis padded. So this means you are getting some padding at the top on the border, so to give some margins at the top and bottom. So if I comment this and if I run this, what happens is you don't see this graph is always, always like going and touching your top margin and the bottom margin. So I sometimes, we want to place it in a bit more, center, and more don't want to, reaching the boundaries. So we just give this axis parity, which is a very useful command. It gives a neat representation. So your graph is always well within the boundaries. You can see not just top and bottom, but on the left and right. So not just top and bottom, but left and right side also. So if you see without this, you can see it's like it's also touching on the left and right boundaries. Yeah, see here. But when you give this parity option, then you see the margin. You can see that top, bottom, left, right, you get a margin, and it's just neat looking. The legend is the same thing. Just put the legend, you get the input data, output data displayed on your STEM graph. Okay, so now that is pretty much on the STEM. So we have seen what are the things that we can do with STEM. Pretty much what we can do with plot, we can be done with STEM. There is a slight variation, maybe here and there is a slight syntax changes, but pretty much other things are the same. Next, I'm going to talk about function plot. So this is a useful feature if you are into a lot of mathematics and you're doing a lot of computational algorithms. Then what happens is this function plot becomes easier way to do it. So what you do here is instead of plotting y versus x, you're going to plot y equal to f of x. So you're going to use y equal to f of x and do the plotting rather than using y versus x. So now I'm creating my x data the same as linear space vectors from -10 to +10 with this in count of 50. Then I'm defining a function. So my f of x here, y equal to f of x, is my sine data. So x data, this is the syntax, at x data sine of x data. So it's going to take the sine of this data and then store it in fx. Then I can call this fplot. This is a function plot. I can call this fx and then I can plot it. And this is the handle. I'm just copying this from the previous STEM. So I'm just copying this here. I'm copying it from the previous and displaying it. So we are going to see the properties modified and looking nice. And then I'm putting the grid on, so that will give you with the grid. You can see this is with the grid, and here when I use h data, I have to again mention grid on, because that is this grid on will apply to my h data. Yeah, so this grid on will apply to this fplot and this grid on will apply to this h data. So now what happens here? So this fplot is functioning, it's just a plot function and it's plotting this function. And why is this useful? So why do you need this? You have plot, you have STEM. We have seen these two can do a lot of things for us, but why do we still need this fplot? When you have a lot of computation, so when you have let us say an equation x square plus y square plus z square, this is happening at different stages of your program. Okay, so you don't have to write that function. So there is a polynomial which is computed x cubed plus x squared plus x plus 1. So this polynomial is computed at various stages of your program. You don't have to write it at each place. So you define a function at one place and just call that f of x. You call that f of x at that place, then it's going to do that function for you. So if I call this f of x at different places of the program, it's pretty much going to give me the sine of x. It's pretty much going to, it now becomes like a function. It's a very simple function. It's just a single line function, and it is pretty much going to do the sine of data. And similarly, if you want to execute a polynomial, it will do that. So this simplifies things for us. You can just call the function, and along with that, if you want to plot it and see, you can call this fplot. So that is why this is useful. So that is one feature that we have for plotting, which is fplot. And now moving on to the last topic of this lecture is your three-dimensional plots, which is your plot3 and STEM graph. We will just say that we have a three-dimensional data and then we want to plot it. So we have the same function plot and STEM, but in a three-dimensional case we have to call it as a plot3 and a STEM3. So these will take 3 inputs as an argument and then it will plot the data. So now I'm giving x data, a linear space vector -10 to 10. Y data is my sine of x data and z data is my cos of x data. And then I'm just plotting it, plot3 x data, and I'm just copying these properties from the previous one. I'm giving the plot3 a h data handle, and then I'm modifying these properties, and then I'm going to see the output. Then the same way for my STEM, and doing the this the STEM3, and it is 50 data. It still can be plotted as a discrete signal, so I'm calling it as a STEM3. So this is my 3D data plot in Matlab. How you can change the appearance and how can, so this is a stem graph and this is a continuous graph. And if you just, I can show you in one, if I go to rotate here, I can show in one dimension, you will be able to see the cos wave, yeah, or cos or sine. So this is the sine wave, because it is consisting of y-axis is your sine data and z-axis is your cos data. So I don't think z-axis we will be able to see. We can see only one axis. Z-axis will appear as a, it will start like this. So we can see, but at least we can see in one axis, we can see this is the sine wave. So this is pretty much the 3D representation. Okay, so that is about the plots for today's class. So we have seen what is a STEM, we have seen what are the properties of STEM, and we have seen what is a function plot, which can be very useful when you're handling a lot of computational coding. You know, it is very much needed there. And then we have seen how to do a three-dimensional plot with your PLOT3 and STEM3. So please, I'll update the code in the description, use it, learn it. Any questions, post in the comment. I'll see you in the next lecture.